So we're back to proofs, everyone's favorite. You guys want the good news or bad news?
The bad news.
The bad news is proofs. Good news? We have a festival for 3 days. It's a Finch festival. Yeah, I know I tried to spin it, but it didn't work. So the rules we're going to cover again. The sheet, if everyone get out your sheets. Anyone missing their sheets? Anyone lost it? Okay, if you lost it, photocopy from someone else because it's going to have all the essential material and you get to use it on the final just like on the midterm, right? If I give you a fresh one, it doesn't have all that crucial information. We're building off of what we did last time. The only thing new, well, there's 2 things new. The last page that we haven't covered yet, that's what's on here. And then on the first page, there's a slight amendment to the strategy. So we're still doing the ding and all that, but there's a slight change, and it's because of the new rules. You guys ready? Should we just jump in? This is your guys' way, Mariah. Okay, here we go. Ready? All right, so what I'll do, just like when I first covered proofs, I'll go over the form of the rules and then give you some examples. If you're confused, I'll try to give you more examples, but the best way is just to practice this. I've got it ordered roughly from easiest to hardest. That's why it's not exactly like the E's are grouped together and the A's are grouped together. All right, here we go. So E-intro, what's its form? Its form says if you're given some predicate with a constant, so C is P, whatever that is, you can claim more generally that something is P. Easy example, if you know that C is a cube, then what do you know? Something's a cube, right? Because if you know, if you got a concrete instance of it, C is a cube, then something's a cube. And that's the logic of E-intro. With me? Anyone want more examples? Okay.
Just
one more. All right. Think of like first time anyone has done anything. You know, I usually use like top of Everest because at one point that was considered to be impossible. Anyone seen like they had PBS specials a while back on Sir Edmund Hillary? Okay, forget it. First person to the moon?
Yes.
Yes, who?
Neil Armstrong.
Armstrong. So suppose I had, instead of C, I had A, right? So Armstrong made it to the moon. So again, prior to that point, it was thought this is not really something that they can do, right? And then you get the start of the space race. So let's see who really can do it. So Armstrong actually made it to the moon. So therefore, it's possible. So therefore, no. Someone made it to the moon. If you know Armstrong made it to the moon, it's possible. That means someone made it to the moon.
It would be EXAX.
Yeah, no, EXPX. P in this case is made to the moon. P is the predicate.
Okay.
Is a cube, is a dodeca. On and on and on. We're good? Other examples? No? Okay. A elim, its form says if you're given a universal, so everything is P. P is, again, any descriptor whatsoever. If you know everything is P, and that holds for everything, then you can stick in any constant you want. A, B, C, D, it doesn't matter. Because everything holds for everything, right? So A is P, B is P, C is P, whatever you want. It's your choice in here. And that's what I have in the sheet. It's slightly different than this, right? It's any constant you choose, any constant you want. More concretely, if I tell you everything is a tet, right? What does your world look like?
Tet.
All tet. So will it follow that A is a tet? B is a tet?
Yeah.
C is a tet? So that's the idea. If you know everything is a tet, then it follows for every single instance. Anyone here read Plato? No, Republic? Oh, good. So if you read Plato, but only one person. This is universal instantiation. The idea that you participate in the forms, which tremendously influence, believe it or not, the Christian tradition. This notion that there's a soul and afterlife and all that, it gets hugely platonized through the tradition. This stuff has a history. You want another example? We're good? Okay, we good, or you want another example? There's the yes, but you didn't answer the question.
Yeah, another example.
Another example? Yes. All of logic is sucks. All logic sucks, right? So that means, well, I already told you all logic sucks. So that means, for example,
Proof sucks.
proofs suck, truth table sucks, bool sucks, LPL sucks, the book sucks. You can stick in any piece of frustration you want in there and it'll be okay. How logical, yes? Even that sucks. It's consistent. Oh well. We good?
Yeah.
Yes. That's why it's dangerous over there. All right, we good? A intro. Okay, now these two are the hardest ones. This one's hard. This is the hardest rule of them all, but it's actually similar to or elim. That's why it's the hard rule. Let's do A intro first. A intro is a little bit difficult to understand and explain. I'll give you several passes at it. It's not very intuitive. So let's go over the form first. How do you actually show that everything is P? I mean, how do you basically prove a generalization? That's hard to do because you're saying it holds for every single instance. Like if I tell you all triangles add up to 180 degrees, how would you prove that? How would you actually show that? You count up all the triangles? You can't do that. You can't finish that in a lifetime, right? The claim when you claim all triangles add up to 180 is an infinite class of objects. So how do they know that this is a fact? That's what underlies a proof. There's a structure to it. So the structure says, to show it, you create a subproof, and at the top, there's this box thing. You haven't seen this yet. I'll show you on Fitch what this is about. Remember the arrow pointing down when you guys do subproofs? Yeah. And I said, you asked, what is that? I said, don't worry about it. Now is when you got to worry about it. That has a function. There's a reason why that was there. That box allows you to choose what are called the constants. It doesn't have to be A here. It could be B, C, it doesn't matter. But the idea is you choose what's called an arbitrary constant. What's arbitrary? What does that mean?
Any.
It can stand for anything, right? Like if I choose someone arbitrarily out at random, I close my eyes and I'm looking at the US population and I just choose someone out at random. That's arbitrary, right? I didn't choose them because of class or looks or whatever else. I just made a random choice, right? That's the idea here. You're saying by choosing an arbitrary constant, you're saying this actual particular really stands for everything whatsoever. If I choose someone out at random and I say, here's a typical American, that's the idea. I'm saying there's nothing special about him or her. I'm just randomly choosing it. I'm saying this person that I just chose at random is standing for all of you. This person, so they're hanging by their hair, and I'm saying this American, blah, 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 right? You guys with me? Okay. Dot, dot, dot. Go through some reasoning. You arrive at the claim that A is P, right? That arbitrary constant is P, whatever it is. Therefore, you can claim if this is truly arbitrary, that everything is P. Well, all right, let's make this more concrete. This is about the only math you're going to get. I already used this proof before. It's the easiest one. There are others, but this is the easiest. Remember the claim all triangles add up to 180 degrees? I cheated when I did that because I didn't tell you I was talking about all of them. I just said, basically, trust me. The idea is you inscribe within, I take two parallel lines. I can make them wide, I can make them narrow. You guys with me? I'm just drawing any old two parallel lines. And within that, I inscribe any old triangle. It could be equilateral, isosceles, it doesn't matter. You guys with me? I call this thing, since, again, if you think about it, the diagram that I'm drawing here, there's nothing special about this particular diagram. I could make it wide, narrow. Again, I can draw any old two lines in there just to make it a triangle. I'm going to call that A, call it Albert the triangle. We good? Okay, Albert the triangle is really standing, that's the idea behind it being arbitrary, is really standing for all triangles whatsoever. But I'm using this as a concrete kind of representation. Yeah? And then I perform some reasoning. This is the dot, dot, dot. This angle is the same as which one? You guys remember? Because it's parallel lines like a train track. Yeah, the one on the opposite side, right? Because it's a straight line going through. And then this one's the same as the one also on the other side. You guys with me so far?
Yeah.
Yes? And then lastly, this one's the same as which one? The one on the top. Since these three add up to, straight lines add up to? 180. How do you know that?
It's a straight line.
Yeah, it's a straight line. It's a fact, but how do you know it? If someone asks you, how do you know that?
Because they said trust us.
Because they say trust us, we're adults? Okay, suppose you had a kid. 0 degrees is flat, right?
Right.
90 degrees is? Straight away. You can actually try and show them that with a protractor, right? Therefore,
That's 180.
that's 180. So that works out, right? And that means since these three correspond to these three,
So 180.
what's 180?
The triangle.
No, what triangle?
The
triangle.
Albert. Albert the triangle is 180 degrees. That's my P, is 180 degrees, right? Albert is the triangle. And since I made no special assumptions about Albert, I can repeat the same process of reasoning on any triangle whatsoever. That means all triangles. So I've just proved a universal via a particular. You guys took I know some of you say you took calculus. They talked about fixing x. There's nothing broken with it. That's the same kind of logic that they use to prove universal claims. All right, no. Forget that. Who wants another example? I can give others. It gets a little strange. You guys want another one?
Yeah.
Okay, here we go. Strange time. It's not totally accurate, but it's good enough to illustrate. I'm actually cheating. It's not purely speaking deductive, but it works well enough. Okay, think of I can use two, but let's just use one for the moment. If you want another, I can give another. Scientific generalizations, like think chemistry. Chemistry, you got the table of elements. Those are like the Lego, the basic building blocks of the universe, right? The table of elements. You guys all know that funky looking thing? Okay? That's like your Legos. They're Legos literally in the universe. You put them together in different ways, you get everything that's out there. That's the basic idea behind how chemistry works, okay? It's more complex than that, but good enough. How do they know, in each of those boxes, what do you have?
Elements.
Yeah, elements like H for hydrogen, and then in there's a?
Wait.
Yeah, think of it as like a description, right? It's like if you go on a dating website. Hi, my name is hydrogen. I weigh so much and so. I'm a Libra, on and on and on, right? So it's got all these descriptors describing its unique properties of self. Kind of make sense? Okay. How do they know that all hydrogen in the damn universe, all of it now, which is not infinite, it's finite, but it's a huge amount, all of it has this same kind of property? How do they do that? Well, here's what they do. The idea behind an assumption, saying pick out a random, arbitrary name, arbitrary thing, it's the same kind of thing here. The scientist closes their eyes and says, look, there's all this hydrogen floating around the universe, and they're like, they're just minding their own business, going about, doing their daily thing, right? And he goes, whack, got it, oh, they're in the hydrogen's like, no, leave me alone, leave me alone. Grabs it, weighs it, pokes at it, and finds, oh, it's got 10 to the minus, dot, dot, dot. That's its weight, right? And it's got all these properties, so that's what gets filled in this box here. The A here is like, that's for hydrogen, has these properties. The dot, dot, dot is the experiments they probe them, poke them, and all the rest. And they find out, oh, here's the profile of hydrogen. You guys with me? And the idea is now they say, look, now they let it go, and oh, fine, it's free, go out in the world, do your thing. Okay? So the idea is, once you do that, you're saying, since I made no special assumptions about that particular hydrogen that I yanked out of the universe, and I'm assuming that they're all alike, that means all hydrogen must be the same. And that's kind of how they arrive at generalizations. Which, by the way, isn't a guarantee, but that's sort of the way science works. Kind of good? Sucks? Sucks for the hydrogen?
Well, I mean, just, we're basing our...
We're basing on the assumption that all hydrogens alike, which we don't fundamentally know, but it seems to work in our universe. And so we think, okay, it must be true. That's the inductive part where it's not deductive. It's not a guarantee. But there might be parts of the universe where it doesn't hold true. And it's, by the way, physicists are starting to claim now that in other parts, there are other potential what are called universes, where the laws of physics are different from ours. Really weird. We're good? Any other? You want another one? We're good? Move on? Okay, let's move on. No questions? All right. All right, here we go. Here's the hard one, E-elim. The reason it's hard, besides it's got all this funky stuff in it, it looks ugly. It's like or-elim. I'll explain that parallel. And or-elim, if you remember, was the hard rule, right? So likewise here, E-elim is also the hard rule. It's the hardest of them all. So let me go over its form first. You got an existential statement. Something is P. You then say, look, do you know what that something is? You don't know. You just know generally something is P, right? So the subproof says, let's name that something. I don't know exactly what it is. Let's call it D. It could be A, B, C. It doesn't matter. Just call it concretely something. So D is the thing that's P. Because if something's P, I want to talk about it more concretely. D is that thing that's P. Dot, dot, dot. I go through some reasoning. I arrive at sentence S, whatever it is. S is just any old sentence whatsoever. If S has no occurrence of the constant I chose, I'm allowed to pull it out to get that. Okay? What? All right, let's use something concrete. Missing persons, murder mysteries, that kind of thing. Just like with or-elim, they tend to work best. So missing persons, there's that show, I never remember, because I never watched it. What's that missing persons show?
Which one?
24? He's missing? Wasn't that Jack Bauer? Huh? No one knows? Oh, you know what I'm talking about. There's shows that people are missing, right?
Yeah.
What do they call missing people?
Opposite.
What's their, if they got a body and they can't identify them, what do they call them?
John Doe.
What if they don't know if it's male or female?
Jane Doe.
Jane Doe if it's female, John Doe if it's male. What if they don't know because they're
Unknown.
no?
No, they call it unknown.
Suppose they're like been left in the water, everything's so degraded that they can't tell gender anymore. What do they call them?
Unknown.
No, there's a name that you can still use. Not John, not Jane, but Doe.
Yeah.
We'll call this subject Doe. We good?
Joe.
Okay. Someone, here we go. Follow, man, you guys blew it, but fine. Someone went missing. That's my P. Someone went missing, right? It's very vague general claim. We got somebody went missing. So we don't want to name, just keep saying someone. We got to name that someone concretely. But
without a trace.
Sure, fine. Okay, so without a trace. So call them what?
So.
Doe. So Doe went missing. Is that their real name?
No.
No, not unless you guys are messed up parents and you start naming your kids John Doe and Jane Doe, right? Then, actually, I always mention this. My mom was a special ed teacher. Had kids with problems. There was this one case. The last name was Hogg. They named their first kid, their first name, Ima. Ima Hogg. And they wonder why the kids got all these problems. Like, you guys are mature. Don't do that. Okay, good? The parents thought it was funny. Something's wrong. All right. So someone went missing. Call that person Doe. That's not their real name again. It's like a placeholder. So Doe went missing, right? The ... here is just reasoning you go through. It's like, okay, so I'm going to make it up here. It's evidence, other evidence you appeal to. So the person went missing in the past hour. We know that the kidnapper, let's say they were kidnapped, right, was going by vehicle. So there's a certain, and they can only go so fast within the city, so there's a certain radius in which we'll find them within that hour, right? Once that radius exceeds a certain parameter, then it's highly unlikely we'll find them. So the S here is, given an hour passed, here's the radius in which we can find them. That's it. We good? Okay, so that's roughly the structure of existential limit. Yeah, it's not very helpful. It's like Euler. This is the parallel I want you guys to remember. It's like an Euler, except there's only one subgroup. Why is it like Euler? Well, if you remember, this is from one of our previous homeworks. When I say something is P, the existential is like a long OR, except it never ends. It's infinite, right? So if I say something is P, when is something true? When at least one thing is yeah. So if I say something's a cube, you need at least one thing being a cube. When is 4 true?
You need one.
Well, you got at least one thing, right? So that's why they're parallel. So something is P expanded out is, that means A is P or B is P or C is P or ... One of these things, at least one, maybe more, has got to be true. So from that long list of ORs, in OR elim, I got P or Q, right? I have 2 subgroups because I'm given concretely 2 options. In this case, I know something is P. I don't have 2 options. I have at least one. I might have more, but all I need is one. So you pick one of those things out. Let's say
A.
Say A, but let's parallel it with this, right? What did I pick here?
D.
Yeah. So this is equivalent to PC or PD or ... right? I picked this one out. That's not the real thing. And I'm saying, let's suppose of that long OR, D is the thing that it's true of. So D is the thing that's P. I go through some reasoning, I arrive at S, and then I'm allowed to yank it out. So it's like OR elim with just one subgroup.